Hello guys, welcome back to part 2 of our revision of the IEB paper 2022 paper 1. So in this video we are going to continue from question 3. The other questions, remember, we covered them in the previous video. If you are new to the channel and you are new to the paper, please join us on this journey of doing revision of grade 12 papers. Don't forget to go back to the previous video and watch from there so that you can understand how to solve equations, how to do algebra, the basic algebra basically. Please don't forget to subscribe also and become part of the channel. So let's start our revision. Question 3, guys. A says, using first principles, find g prime x if g of x is equal to negative 3x squared. So we are going to do differentiation here. We're going to find the derivative from first principles. Now when they say from first principles, we always use this formula here: f of x plus h minus f of x all divided by h. Okay, now this comes from the limits, so we will not forget to put limit before we start our differentiation, and then our limit must be as h approaches 0. Now in my case, you'll notice that I used f instead of g. I'm just writing here the formula, so I will have f of x there on the left hand side, the derivative of f of x. Now using this formula, let's try to apply it in our g of x. What I'm going to do now, I'll write g of x instead of f of x. So we are finding the derivative of g of x. This is equal to the limit of h as h approaches 0. And then now we have to put in our equation. One thing I want to remind you of is when you're going to plug in the equation into the formula, where we see x, we are going to plug in that guy. This simply means that the x value in the function has been manipulated by adding h. So where we see x, we are going to add h. Now to substitute here, we have got negative 3x squared. I'm going to write x plus h, all of that must be squared, minus the function itself, and our function was g of x. That means it's negative 3x squared, all divided by the value of h. And then to move further now, we have the limit as h approaches 0. I'm going to multiply the bracket. This is negative 3. When you multiply the bracket, you expand, meaning you're going to do FOIL, which will give us at the end, in other words, it's x plus h squared, which is x plus h and x plus h. Then you start now by applying FOIL here. Please do it on the side. I'm just going to write it here quickly. This would be x squared plus 2xh plus h squared, and then close bracket. Yes, that's our FOIL. And then on the other side, we've got negative and negative, which should give you a plus 3x squared all divided by h. Then we further multiply the negative 3 inside the bracket. Please do not forget to write the limit as h approaches 0. To multiply now the bracket, is going to be negative 3x squared, negative 6xh, and then negative 3h squared plus that 3x squared all divided by h. And then we further go into the next step, the limit as h approaches 0. If you notice here now, we have got like terms. Negative 3x squared and 3x squared will cancel because they will give you 0. And then we are left now with negative 6. Now what I'm going to do here is I'm going to try, this is what we have. I'm going to try to remove the h at the bottom there so that we will not have an undefined derivative once we plug in the value of 0 into h. I will do that by taking out a common factor of h. You are left with negative 6x minus the 3h. Remember, all of that is still divided by the value of h. Okay, and then if you notice now, we're going to divide here. We divide h by h. They give you 1, or the common language that we use, we say they cancel. Therefore, this is what I have. The limit as h approaches 0, that's negative 6x minus 3h. Now I can substitute. When I substitute, I will say therefore the derivative is equal to negative 6x minus 3, and then substitute in the value of h, which is 0. Once you substitute the value of h, you do not write the limit part. Therefore, the derivative now from the first principle will be equal to negative 6x. There you go. You've answered the question fully, and then you get your marks. If you got confused somewhere, please pause the video, try to go back and see if there's anything that you missed. Moving on to question B. Still on question 3, question B. Now find the derivative of f of x if f of x is given as that function. Okay, guys, the best way to find a derivative is to make sure that you have a linear equation or expression whereby all your terms have got a denominator of 1. Okay, now before I do that, I just want to quickly write down a formula that is going to guide us. Let's say you're given f of x as a to the power of n. Okay, now to derive this from the rules, the derivative is going to be f of x is equal to f of x is equal to, you multiply the coefficient here, so this will be n times whatever coefficient is there, and then you have the variable n minus 1 at the top. So this is going to be the formula that's going to guide us there. Now to derive here, let us try to first make the equation linear. That means f of x is equal to 5 over 3. Okay, 5 over 3 is a function, is a fraction, and then x there with a negative exponent, we can leave it like that, it's fine, plus cube root of x5, so this would be x to the power of 5 all divided by 3. That is also fine. Okay, what I tried to do here is to try and remove the variable as a denominator. Yes, that's what I meant to say at first. Try to make your equation have a variable that is not a denominator, so your variable must move from the denominator side. Now to find the derivative here, that's when I'm going to write my f prime of x, because now I'm finding the derivative. Then remember what we said here, using the rule, you multiply the coefficient of x by the exponent. This would be negative 5 over 3x, and then using the exponent, you are going to subtract 1, plus we do the same thing there. Or before I move on, let's try to save some space. This one, when we simplify it, it will give you negative 2, and then on the second term, we're going to multiply the coefficient, which is 1 there, with 5 over 3, which will give you 5 over 3 x and then we say 5, let's do this one on the side, 5 over 3 minus 1, and then what does this give you? 5 divided by 3 subtract 1 gives you 2 over 3, meaning the exponent of x now is 2 over 3. Please don't leave your answer here. Remember to write it with positive exponents. So this is 5 over 3. Since x has an exponent of -2, from the laws of exponents, that goes to become a denominator to a positive exponent, plus we still have 5 over 3 there. And then this one, it's going to be x at the top, x to the power of 2, and then a cube root there. Now this is derived, fully derived. That is the derivative of f of x. Moving on, guys, to question C. In the diagram below, we have a function of f of x, which is x squared minus 2x minus 3. So this is that function. A is the y-intercept and B is the x-intercept. So I'm just going to highlight that part. A is the y-intercept and B is the x-intercept. So know the difference between the two, y and x-intercept. Calculate the coordinates of A and B. That is the first question. Let us start off with A. From A, since A is the y-intercept, hope you guys will remember now from this formula, ax squared plus bx squared plus c. The value of c here by default is the y-intercept. Okay, the value of c is the y-intercept, meaning the value of -3 will be the y-intercept. Now, just to write the coordinates of A will be at y, the x value is equal to 0 right there. The x value is 0, but y will become -3. So the value for, or the coordinates for A will be 0 is to -3. You get your mark there. And then let us try now to find the coordinates of B. Coordinates of B, at B, y is 0, but we do not know what x is. Now this is where we have to find the x coordinates or the x-intercept so that we can be able to find the one for B. To find the x-intercept, you must let y to be 0. Now using this formula f of x, we will say 0 is equal to x squared minus 2x minus 3. To solve this equation, 2 brackets there, not x squared. So the factors will be x times x, 3 times 1, and then the middle sign goes to the bigger factor, plus, and then the values of x, it's -1 or x +3. Now on this side of the Cartesian plane, x is a positive value. That means the positive value of x, which is 3, is the coordinate for B. Therefore, I'm going to say my B coordinates now, or let me write it here rather. Therefore, my B coordinates will be 3 is to 0. Remember there, we made our y to become 0. And then the value of x is 3 because we calculated it by solving the equation. I'm just gonna put this -1 value here, the one we got for x. It might help us in future. So there it is, -1, and then you have 3 there. That's fine. So we found the coordinates of A and B. Let's look at the next question. So the next question is, determine the coordinates of determine the coordinates of the point on F where the tangent to F is parallel to line AB. Okay, let me try to zoom out, scroll up, because I want to read the question, guys, and while looking at the diagram. Okay, so the question is, determine the coordinates of the point on F. So the point is on F, where the tangent to F is parallel to line AB. That's line AB, meaning we are looking for a point somewhere there, which is gonna be parallel to line AB. Okay, so we're looking for the coordinates at that point. Now, this is a parabola. If we can find the derivative at any point, meaning if we can find f prime of x, that will be the gradient at that point. Okay, so let us quickly do that. Let's quickly do that. So the equation of f is x squared minus 2x minus 3. So f of x is equal to x squared minus 2x minus 3. So let us find the derivative at any point. I'm also going to label here at any point in the graph, at any point. So the derivative now, just using the law, I'm going to say 2 times the coefficient, and then 2 minus 1. And then for the second term, it's going to be the positive exponent of 1 multiplied by negative 2, which is negative 2. 1 minus 1 will be 0, meaning this is the derivative. The derivative of a constant number is 0. So this is the derivative at any point on the graph. But remember, the question says, look for the coordinates. Now, and then another clue is that our tangent is parallel to line AB, meaning we have to find the gradient of line AB, which will be we'll find it by saying delta y over delta x. This is this is y2 minus y1 over x2 minus x1. Okay, so once we find this gradient, now let me explain why I'm using these two. If we find this gradient of the line parallel to line AB, okay, this will equal to our derivative. Remember, this is for any point on the graph, but this is specifically for the line parallel to, or this is specifically for AP. Okay, so at the end of the day, what I will do is to say f of x will equal to MAB, and then here I will get the value for x. Then you'll see how we're gonna find the coordinates. So let me go straight to the coordinates of A and B. We said A is 0 is to minus 3, B is 3 is to 0. Okay, let me take my red color. So we said A guys, I forgot now, but B is 3 is to 0, or A is 0 is to minus 3. Perfect. Now let us find the gradient of AB. 0 minus negative 3 all divided by 3 minus 0. This is equal to, so it's going to be 0 minus negative 3 divided by 3 minus 0, which is 1. So the gradient of AB is equal to 1. Now I said we are going to take the derivative of f of x and make it equal to the gradient of AB. The reason why the gradient of AB is because parallel lines have got the same gradient, and then the derivative of f of x is a gradient of the graph, but at any point. So the derivative, we solved it to be 2x minus 2. This is equal to 1. Therefore, let's try to find x here. So we'll say 2x is equal to positive 2 plus 1, which is 3. When you divide that by 2, the answer for x is 3/2. Okay, now we found the value of x of this point. We found the value of x of this point. We need now the y value. So to find the y value, take the value of x and substitute it there, okay, so that you can get the y value. So let me quickly do that. My apologies guys for scrolling up and down. I am trying to relate the question to the diagram here. So f of 3/2, meaning we're looking for y at 3/2. This is 3/2 squared minus 2x, and then our x is 3/2 minus 3. And then let's see what this value is gonna be. So it's 3/2 to the power of 2 minus 2 bracket 3/2, and then minus 3 at the end. The value of y is negative 15/4, negative 15/4. Therefore, the coordinates now of that point, of that tangent, will be 3/2 is to negative 15/4. Now we have answered the question. Okay, so from here we moved there, and then from there we moved there. Okay, if you got confused somewhere, please pause the video once again. Pause the video and look at how I ended up with the coordinates there. Question number 4. The nth term of an arithmetic sequence. So this is the rule. The nth term of an arithmetic sequence is given by Tn is equal to 5n minus 2. Question 1 says determine the number of terms in the sequence if the last term is equal to 198, and it's 2 marks guys. It should be easy for us. So the last term would be the value of Tn in our case. Here we are looking for n. This is one of the questions in the lower grades. They ask it as what term will equal to 198. Okay, which term will equal to 198? Now we're going to look for that term. So it's Tn 5n minus 2. Tn is gonna be 198 5n minus 2. Then we transpose the 2 to the other side, which will become a positive, and then resulting in 200. You have 5n. When you divide by 5, you're gonna get your n value as, so it's 200 divided by 5, which will be 40. Let me confirm that with the calculator. So 200 by 5 is 40 years. Now the question was determine the number of terms. The number of terms is that there are 40 terms in that sequence. Question number 2, determine the sum of all the terms of the sequence. So we need a sequence here guys before we start. Remember our Tn was 5n minus 2. Let me quickly confirm that Tn, yes, it's 5n minus 2. So how do we find the sum now of the sequences here? To find the sum, let's first find our sequence. Starting from term 1, 5 times 1 is 5 minus 2 is 3. 5 times 2 is 10 minus 2 is 8. 5 times 3 is 15 minus 2 is 13, all the way till the last term, which was 198. There we go. Now let us try to find the sum here. Finding the sum, we say the sum of the terms is n divided by 2 bracket 2 times a plus n minus 1 multiplied by d. Okay, so to find the sum here, we have 40 as our number of terms divided by 2 bracket 2 times a represents the first term in the sequence, plus n is the number of terms once again, minus 1 multiplied by d, the difference. The difference is that one, guys. That's the difference. Sorry, that's the difference, which is 5 times 5. Then the answer that we get here will be the sum of all the 40 terms. So to quickly do that, we say, let me write it. So it's 40 minus 1 times 5 and close bracket. And this is the answer that we get. Hey, it's too high, guys. Let's confirm what did I do wrong here. Oh, I didn't put in the plus sign. Okay, yeah, now that's the answer. So it's 4,010. That's the answer. That is the final answer. Then you get your 3 marks, guys. You get your 3 marks. There's another way, there's another formula that you may use if you know the last term of the sequence. Just like in our case, because we know the last term it's 198 and we know the first term is 3 there. Another formula would be Sn is equal to n divided by 2 bracket a plus the last term. Some textbooks or some people will label L as Tn, meaning the last term. So S40 is equal to 40 divided by 2 bracket 3 plus the last term, which is 198. And then let's see what answer are we going to get here. If I put this in a calculator, this is gonna be 40 divided by 2, we also get the same answer, 4020. So choose the method that works well for you. Okay, question B says the sum of the first n terms of a geometric series is given by determine the 9th term of the series. So we have here the sum of the first n terms of a geometric series is given by this equation here. The question is determine the 9th term of the sequence. Okay, what I'm gonna do here is say Sn is 8 minus 2, 3 minus n. Okay, determine the 9th term. So we are looking for T9, not S9. Now, the formula that I'm going to use here is if you are looking for any term, Tn, if you're looking for any term, you can say S of that term, meaning the sum of term 1, term 2, term 3, all to that specific term, minus the previous sum of the terms, okay, meaning minus S n minus 1. In other words, I'm saying if we're looking for T9 here, we're going to look for the sum of the first 9 terms minus the sum of 9 terms minus 1, meaning when I simplify that, term 9 would be S9 minus S8, S subscript 8. So we have to look for these two. Let's look for the sum of the first 9 terms and the sum of the first 8 terms. When we subtract these two, we are going to get our T9. Okay, this works also for I'm just extending now the knowledge, guys. This works also for, let's say I said find term 17. Now what you'll do to find term 17 using that formula, you'd say as the sum of the 17 terms minus the sum of the 16 terms. I hope that makes sense. Okay, if we make it practical, let's say I have this sequence here. Let's say I have 2, 4, 6, 8, 10. Okay, let's say I have 2, 4, 6, 8, 10. This is term 1, that's term 2, that's term 3, that's term 4, that's term 5. Then the question says, given given the formula, they give you the formula, and then they say find term 5. Now, in order for you to find term 5, you'd say the sum of the 5 terms minus the sum of the 4 terms. So the sum of the 5 terms, meaning you have to add all 5 of them. So let's try to do that. This would be 2 plus 4 is 6, plus 6 will be 12, plus 12 plus 8 is 20, plus 10 is 30. So the first 5 terms are 30 when you add them together, minus S4, meaning minus the sum of the first 4. Okay, so 2 plus 4 is 6, plus 6 is 12, plus 8 is 20. Now this leaves you with term 5 being 10, because 30 minus 20 is 10. Okay, so I'm going to use this formula here to answer that question. I hope that I didn't lose you guys. If you were lost, please just skip this part, or please try to rewind the video and rewatch again. I hope that it makes sense. So let us try now to answer that question. In order for me to find T9, I said what I'm going to do is that I'm going to find I'm going to use this formula, meaning T9 is equal to S9 minus S8. So let us try to find term 9. Term 9 would be S9, so I'm using the formula now. This is going to be, let me put it in brackets. This is going to be 8 minus 2 to the power of 3 minus 9. And then I subtract S8, meaning it's going to be 8 minus 2, 3 minus 8. And then this will give us T9. So let me quickly put that in a calculator. So putting it in a calculator now, we have bracket 51164. So it's 511 over 64 minus the second term now, the second part of the equation. So I'm just going to substitute there. Therefore, the ninth term, this geometric series is gonna be, so we say it's a fraction of 511 divided by 64 minus 255 divided by 32. This gives me 1 over 64. 1 over 64. That's the answer. That's the answer. I hope it makes sense, guys. I hope it makes sense. Okay, guys, question 5. Let's see if we can do question 5 quickly. Question 5. In the diagram below, let me just show the diagram. I think I'm gonna zoom out a lot here, so please, guys, bear with me. So this is the diagram we are given here. It says, let me use a different color. Let's use blue this time. Yes, let's use blue this time. So g of x is given as x cubed minus 3x. So this is our graph G. A and B are the turning points of G. There is A, there is B. C, O, D are the 3x intercepts of G. C, O, D. One of them is 0 is to 0, guys. Okay. Now, what does the question want? Let's go straight to the questions. The first one, determine the coordinates of A and B. Please remember, guys, what you look for when it comes to a cubic function, because this is a cubic function. So know those first derivatives, second derivatives, the turning points, points of inflection, know all those things, okay? So now going back to the question, says determine the coordinates of A and B. To find the coordinates of A and B. Oh, sorry about that. Okay, so to find the coordinates of A and B here, as you can see, they are the turning points. Now remember, in a cubic function, you have your g of x in our case, which will be x to the power of 3 minus 3x. Now in a cubic function, if we can get the first derivative of that function, this will be a graph of a parabola. Now the x-intercepts of the parabola will be the turning points of the cubic function. So let us find here the first derivative would be 3x to the power of 2 minus 3. Okay, so this is the first derivative, which is a parabola. Now since it's a parabola, let me just make a rough sketch. This one has got a positive value of a, meaning it's gonna go like that. So this is my sketch. It goes on like that. My sketch might be invalid, guys. Okay, it's not drawn according to scale. Sorry, I was supposed to turn here. So this is my sketch of the first derivative. Now I'm saying to you, the sketch of the first derivative, the x-intercepts will be the x values of the turning points of the cubic function. Okay, so we found our first derivative. Now let us try to find the coordinates of A and B. I'll just write it here. I'll do it here, guys. This one I won't answer the below because of I'm avoiding to scroll up and down. So this is g prime is equal to 3x squared minus 3. Let us find the value of x. This would be 0 is equal to 3x squared minus 1. I just factorized there, which in the end we have x squared minus 1. When we transpose the 1 to the other side, you get x squared, meaning the value for x is 1 plus 1 or minus 1. Okay, plus 1 or minus 1. That means at A, the value of x is minus 1, and we have to find the y value. At B, 1 is positive, and then we have to find the value of y. Now to find the value of y, I'll say g of x into -1 is equal to -1 cubed minus 3 times -1. Now I'm taking it back to the original function because I'm looking for that value of a there. Okay, so this gives us -1, sorry, and then negative 3 times negative 1 will be positive 3, which is equal to 2. And then the second value of y would be g into positive 1 is 1 minus 3 into 1, which gives us 1 minus 3, which is negative 2. That means at a, y is negative 2. At a, y is negative, sorry, my mistake, because we did it here. Y is positive 2, and then at b, y is negative 2. Okay, so the question was find the coordinates of a and b. So we found a to be negative 1 is to 2, and b to be 1 is to negative 2. There you go. So these are my coordinates now. I'll just write them here. We did the calculations at the top. Please don't do this, guys, when you write your exams. I only did it because I was avoiding scrolling up and down. So this is the value of a, this is the value of b, or rather the coordinates. Now the second question, on the Cartesian plane above, sketch g of g, the first derivative of g. Okay, so on the Cartesian plane, let's try to sketch now that graph. Okay, in order to sketch the graph, guys, we need the y-intercept and the x-intercept. So the y-intercept, where is my second derivative? There it is. So the y-intercept is going to be negative 3, and then negative 3, and then plus and minus 1 here are going to be the x-intercepts, because we did calculate them, okay, from here, all the way from here. Now to sketch the graph, this saves us a lot of time. We are just going to use this as the x-intercept, then we need the y-intercept. So this is negative 1, negative 2. Let's say we have negative 3 there. To sketch this graph, this is what I have. My turning point is right there and goes up just like that. That's what I've sketched now. So this is the graph of the derivative of g of x. Guys, I know it's a bit messy. Please work with me, okay? Let's see how many marks are here so that I can give you tips what they're marking. Okay, it's 3 marks. Basically, when you graph, is the shape corresponding to the value of a on the standard formula. Okay, and then they are looking for the x-intercepts. The x-intercepts are the x-intercepts corresponding to the ones that you calculated, and then the last one would be the y-intercept. So it is very wise for us to label the y-intercept here as negative 3. Okay, yeah. Then the next question would be, so that was B, and then question C says determine the equation of the tangent. Determine the equation of the tangent. This is a straight line. Okay, determine the equation of the tangent to the original function of g of x at x is equal to 3. At x is equal to 3. Okay, now at x is equal to 3, what do we need? We have our equation g of x is equal to x to the power of 3 minus 3x. And then we did calculate now the first derivative as 3x to the power of 2 minus 3. Okay, and then they say here determine the equation of the tangent to the original function g of x, whereby x is equal to 3. Okay, where x is equal to 3, we need guys the y value. That means where g of x is equal to 3, what is the y value? Now the y value is going to be 3 to the power of 3 minus 3 to substitute x with 3. Okay, let's see what this gives us. So this is 3 to the power of 3 minus 3 times 3. This gives me 18. So I have the coordinates that I'm going to use. That means at that specific point, I have a coordinate of 3:18 that I'm going to use. Okay. Now I advise using this formula because we're looking for a straight line. Y minus y1 is equal to m into x minus x1. This is an equation of a straight line. When I go there and substitute, y minus 18 is equal to m into x minus x1, which is the value of 3. Okay. Now what we need is the gradient at that specific point. We need a gradient at that specific point, gradient at 3. That is why I have here the gradient or the first derivative. Now the gradient at any point is shown by that equation. That means the gradient at 3 is gonna be what? We say 3x is 3 raised up to 2 minus 3. Okay, so this will give us the gradient at a specific point, and our specific point is 3. And then let's see what that gradient is gonna be. It will be 24. Okay, now I got the gradient at 3. Let me just make a note here. This is the gradient of the function at 3, at x is equal to 3 basically. Now I'm going to take my gradient, which is equal to 24, and substitute it in the value of m. So I have 24x minus 3. And then let us find the equation now of the tangent. So this would be 24x minus 3 times 24 would be 72. So it's minus 72 plus 18. Okay, 72 plus 18. Therefore, this is y is equal to 24x and then negative 72 plus 18 gives you minus 54. So I say minus 54 there. That is my equation of the tangent at x is equal to 3. Okay, then let's see if we have another question. Okay guys, we will end it there for today. Let's end it there for today. Then we'll carry on in part 3 when we go to financial maths. Yo guys, this is a long paper. Let me see how much time they give you to complete this question paper. Yo, 3 hours. Yo, okay, it makes sense why I can't make just one long video, guys. Can't make a 3-hour video. It's too long, but maybe one day. Okay, thank you so much for tuning in. Thank you so much for watching the video. If there's something that you didn't understand, just leave it in the comment section and then I'll attend to it. Enjoy your day.